chosen for decommissioning. The asset chosen for decommission is offshore platform. Offshore platform is a structure for exploring, extracting, and processing petroleum and natural gases. For this report, the offshore platform studied for decommissioning process is the Ketam platform in Sabah. The platform was installed in 1984 and production cycle at the platform was halted in 1997. The decommissioning of the platform was done in 2003 as the platform was totally removed and disposed offshore. However, the pipeline of the platform was left in situ.
Despite the decision-making in decommissioning asset, which is not only limited to the date for the acquisition of the decommissioning planning, it's also as critical as the asset acquisition that consists of multiple real-time strategic choices, which every decommissioning approach are subjected to the international regulatory policies and conventions. And generally, the decommissioning of an offshore platform has three stages, which are pre-decommissioning, decommissioning execution, and post-decommissioning, which require professional workforce and advanced approach in achieving the most environmentally sustainable strategy. With life period in between 20 to 30 years old, most of the commencing 70s platforms are going to be decommissioned, with around 300 oil platforms involved. Despite the current situation where most of the platforms are approaching the end of their service life, but less of them are going to be decommissioned because of the insufficient legislative and regulatory compliance to assist the decommissioning process.
For abandonment planning, a file review is made few years before the sign date by which the Ketam platform's production level is anticipated to drop below non-economic rate. Then by using the existing data of geological and geophysical work, a review is done to confirm the decision of decommissioning of the Ketam platform. The decommissioning process consists of three phases. For pre-decommissioning phase, a precise planning is made to choose the decommissioning option in all possible aspects. Next is the decommissioning execution phase, where the offshore installation decommissioning activities are done according to the process proposed by the person in charge and approved. Lastly, in post-decommissioning phase, site reviews and observations are made to observe such things as the environmental changes, environmental recovery, as well as the impact of the process made during the decommissioning of the offshore installation.
According to the US Department of Interior's Bureau of Ocean Energy Management Regulation and Enforcement, platforms that have been dormant for 5 years or more must be decommissioned within 5 years. However, every offshore platform that needs to be decommissioned needs to comply with several laws and guidelines. Petronas decommissioning norms are based on the international guidelines as well as lessons learned from Shell's Ketam and Baram 8 decommissioning projects. Furthermore, the Petronas decommissioning guidelines indicate that any removal must be based on a case-by-case decommissioning evaluation. Several international conventions, treaties, and national laws deal with the decommissioning of offshore production facilities. To summarize, all laws require the removal of oil and gas platform infrastructure to ensure the safety of navigation, the environment, and other sea users.
Decommissioning causes all reasonable expenditures and expenses associated with the sealing, decontamination, dismantlement, removal and disposal of the offshore facility structures, system and components at the end of the useful life. There are 5 cost drivers for decommissioning costs. In this case, disposal costs will be the main cost drivers, which involve well, pipeline, and platform abandonment. According to Sarawak Shell Berhad, the total of the Ketam decommissioning was 62.44 million ringgit. The breakdown of the total cost can be illustrated in this table. The actual cost is different with the expected cost by Ketam decommissioning BPEO assessment, which is 27.6 million ringgit. If we compare the forecast of the total decommissioning expenditure by the UKSC with this actual cost, we can see the pipeline and platform abandonment rates are significantly higher than those projected by UKSC. This could explain the difference between the estimated cost by BPEO assessment and the actual cost announced by SSB.
Generally, there are 5 general stages to manage risk, which are identifying the hazard, determine which hazard can pose a threat and how threats can arise, evaluate existing risks and determining countermeasures, implement the determined countermeasures, and lastly, review the risk assessment made and update if necessary. During the decommissioning of Ketam offshore platform, some of the hazardous activities identified are heavy lifts, working at height, marine movement with communication and scaffolding. These activities pose great risk and hazard to the personnel working on the field. To overcome this risk, the countermeasure is ensuring that the equipment used are in good condition. Other countermeasures is to make sure that only trained personnel do the hazardous activities such as diving and working at height. Other general steps to manage risk during asset disposal is to conduct health and safety environment HSE training to all field operators to equip them with necessary safety practices. A thorough risk analysis need to be done before any activity during the commissioning project to identify all possible risks and come up with the necessary countermeasures.